Welcome back to another video. Today I'm going to do something completely different. It's going to be kind of a question answer kind of thing. I've never done a video quite like this. I'm hoping that I can turn around videos quicker and just answer you guys' questions and still be helpful. The downside is they're not going to look as polished. I'm not going to be spending as much time on them. If you like this style, then let me know in the comment section that you like it. If you don't like this style, then let me know you want the more polished stuff and I will produce those instead. Um, anyways, the question is, how do you control using a VFD with a dancer arm and a trim pot? So it's kind of a weird question. Let me draw it out for you. So right here in front of me, I just opened up MS Paint, and I'm going to draw kind of what it's trying to say. So for those who are not familiar with dancer arms, basically they are a wheel. Hold on, let me try this again. They're basically a wheel, and in front of the wheel there could be something called a nip, which is two circles. Okay. And then maybe there's another wheel over here, and basically what happens is we have paper or something. So I'm going to draw paper kind of coming through here, and then it comes underneath this circle here, and then it goes on top of this circle, and then it goes somewhere else in the machine. Oops. Okay. So that's what this blue line represents. So the material is going in that direction. Wow, that's a terrible arrow. It is going in this direction. Okay. And this little wheel right here is connected to an arm. Okay. And it is basically this little arm here, right here, lets this wheel go up and down. So this little wheel will move up or it moves down. And the reason it moves up and down is because this material right here, that's blue, this paper, will get more slack or it'll get tighter. So if the paper gets tighter, the wheel will move up, right? And if the paper here gets looser, it will move down, okay? And the idea here is you want this dancer to be somewhere in the middle. You don't want this dancer to be all the way at the top, and you don't want it all the way down here. So what we do is we put something called dancer feedback, and there's like a little potentiometer over here, or some sort of device that reads the position of this dancer arm, okay? And the question is basically asking, how do I control a VFD with a dancer arm and a trim pot? Well, a trim pot is just a potentiometer, okay? It's just like a round knob that you turn with your hand to set a position for this dancer arm, right? So maybe you want the dancer arm to be in this position, but maybe you don't. Maybe you want the dancer arm to be maybe more up here, right? You want it to be up this way. Sorry about the graphics, but regardless, that's the question that's being asked. So what I'm going to do here is I'm going to illustrate the system using a M700 drive, and I'm going to use all the analogs, right? I'm not going to use any networks. I'm not going to do anything. This might be a little bit overkill. After I illustrate it on here on how the PID would be set up, so you get a visual understanding, I'm going to go to Connect software and actually go through the parameters on how to set it up itself, okay? So the first thing to note is we have a drive, okay? Here is our drive. And the drive is going to have several inputs. Now, I'm going to use all three inputs on the M700, and each one's going to be connected to something different. So the first analog is going to be connected to a potentiometer, okay? And that potentiometer is going to set the speed. It's going to be the speed that I want the system to run at, right? and it's going to be in RPM. That's where we're going to define it today. And the second potentiometer, okay, this one's going to set the dancer position. Okay, so remember, you could have it 50% up or 100% up or 100% down or anywhere in between. That's the job of this analog input. It's going to be, again, a knob. And then the last one is where we're going to connect that little dancer arm, right? We're going to have that little feedback thing with the, we'll draw it again, you know, the little arm and then the bigger roller. Okay, so this is going to be the actual feedback, the position of it. So inside your drive, you will have a PID block, okay? And the PID block will have basically three things for the settings. It's going to have a P, an I, and a D. In most cases, you won't need to adjust the D, but you may need to adjust the P to something value, right? So maybe this one will be a 4, and maybe this will be a 2, and this will be a 0. This is what you got to play with when you're trying to tune the PID so it's not bouncing around too much. But I'm not going to cover that so much today. We're just going to cover how to set it up. All right. So the first thing I need to do is I need to bring this into the PID system, right? So there'll be an input here. So this will be feedback, right? Feedback. And then there'll be a reference here, okay? Now, we kind of covered this in that PID video I made a year or so ago, and it talked about this a lot more. So this is kind of what we're talking about again. And then that PID stuff, that input will get subtracted from each other. And that produces the error, and that gets fed into this PID block, okay? On the output side, it will produce some value, okay? We don't really care too much about that. What we need to do, though, is we need to have this trim the speed command, okay? So what we need to do is have this subtract, or maybe add. Maybe we'll have it add, okay, to the speed command. And so this is basically what we're going to try to set up inside the drive. And basically what happens is this pot sets the speed. This pot sets the position that this is supposed to be at. And if this is too low, then it will add speed. And if this is too high, then this will subtract speed, right? You'll get a negative value here out there. So to do that, all we got to do is come over here to connect. And here's our M700. And I'm going to go to block diagrams. I'm going to do most everything through the block diagrams. I'm going to go to menu 7. And you can see I have, whoops. You can see I have 3 analog inputs on this, okay? And this one's going to be used for our set speed. And by default, it already is. I don't have to change anything. It's already being mapped to the correct parameter. So there's nothing for me to change here. This one, I'm going to set this to 0 for now, okay? And here's analog 3, okay? So I need to hook these two to the PID system. So if I come over here on the left side where the block diagram is, you'll see here's our PID controller. Remember that I drew that square with the proportional gains, the integral gains, and the differential gains? Well, in front of that is the air, and we need to come on over here, and we need to link these two locations, okay? So these little question marks right here, yeah, so what I'm going to do is I'm going to link this to this parameter right here, 7.002. We're just not even going to use these parts. I'm just going to use 7002 and 7003. So I'm just going to type right here, 7.002, and I'm going to type 7.003. Now what happens is the inputs are all set up. Good. We come back here, come down to the PID control, and we need to enable this. This is the PID enable. Turn this on. You can have a digital input tied to this if you want to turn it on and off or whatever. It sometimes is a good idea. Or another thing that sometimes is good is to tie this to like drive active. That way the PID is disabled if the drive is like turned off. Okay, so it just disables the PID loop. So I kind of like that. Whoops, that's the wrong source. So basically what these are is the parameter numbers that's going to be controlling the PID loop. And then right here is a percentage, like how much do I want to allow the PID to control the system. And I would not give the PID the ability to add 100% speed or subtract 100% speed. It's too much trim. So what I would say is maybe 10% or maybe negative 10%. This is something you got to decide for yourself. And then what we need to do is we need to map this output of this PID to the trim. Remember back here? Remember the output? I need it to come back here and map it here in some way. So what we're going to do is in menu 1, right? Here's our analog 1, and it comes all the way through all these little switches, and you'll see at the bottom there's something that says percentage trim, right? And that's what I'm going to do. I'm going to map it right here, and what happens is that gets added to the commanded speed that you're doing. So all I got to do is type in this parameter 1.038, 1.038, and then after that you would of course save the settings in the drive if I was online, and then the system would work and you'd see this trim thing happening and it would add speed to keep that dancer middled. That's basically it. The only thing I would recommend you checking though is your ramps probably need to be pretty quick. Slow ramps will get in the way of a dancer, so maybe half a second might be good. Maybe turn them completely off. That's kind of up to you, but that's everything. If you have any questions, please let me know. Thank you for watching. If you enjoyed the video or you found it useful, please subscribe or share it with somebody. And I'll see you next time.